Today I am going to discuss assignment problem. Normally the assignment problem is a minimization problem. In that case, generally the cost figure or time required to complete any job is given. That's why the normal assignment problem is a minimization problem. But in this case, this problem is a maximization problem. You have to solve it. There are 5 jobs A, B, C, D, E and 5 machines. And the figures are not cost or time. This is the profit figure. Say this. If the job C is completed by this machine, then the profit will be say rupees 5. 5 maybe million, maybe lakhs, like that. The same job can be done by all these machines. And the profit for different machines are noted here. If this job is done by this machine, the profit will be rupees 10. If this job is done by this machine, the profit will be 4. In this way, the profit figure is given in the matrix. And our objective is in the case of profit, maximize. We'll always try to maximize profit and minimize cost. As here the profit figure is given, that's why we'll maximize it. But we know the Hungarian method, which is a minimization technique for solving assignment problem. Then what you have to do, at the beginning, you convert this maximization problem to minimization problem. That is only the difference from your previous problem. How will you do it? You find out the maximum profit element from the figure, which is the maximum element. 5, 11, 12, 9, 12. You check which one is the maximum. In this case, 14 is the maximum. You subtract all the elements of the matrix from 14 and then prepare a revised matrix. This is the first step. What is the significance of this? If you subtract all the profit figures of the highest profit, that means that is the opportunity loss. Say in this case, you have to subtract 5 from 14. That means this is 9 in this way. That means this is the opportunity loss. 14 could be maximum profit for this matrix, and we are subtracting all the elements from this maximum profit of the matrix. This is the first step. So I am doing that first. Next, this will be 3, then this will be 4. I am writing on the same matrix as there is a limitation of space. We will utilize the same space repeatedly just to save the space. But in your case, you do it in a separate page or separate table. This is say table 1. Next, 12 you have to subtract from 14. Then this is 4. Now 9, 3, 4, 2, 10. Sorry, 4. This is the figure 12, I think. The figure, that's why 2 and then 14 means 10. This is the first row. Okay. Now 5, 9, 3, 4, 2, 10. Next. This is to subtract 2 from 14. That is 12. In this way, just to save time, I am writing all the elements. In this way, this will be 10. This will be 10. Then 5, 11, 9. 5, 5, 11, 9. Prepare it this way. Next 11, 2. This is 11. This is 2, 9, 0, 8. This is 9, 0. 14 minus 14 is 0. And then 8. 8. 8, 0, 10. 8, 0, 10. And then 3, 7. 3 and 7. The last row is 7, 7, 7, 5, 6. 7, 5, 6, 2, 9. 2, this is 9. In this way, we will convert a profit matrix to loss matrix, means opportunity loss matrix. And if you minimize the loss, that means automatically you will maximize the profit. That is the concept. Now you will proceed as usual by Hungarian method. Okay. This is a square matrix. That means it is a balanced problem. Now we can apply the Hungarian method on this matrix to find out the best allocation. Now this is again a minimization problem. So I am going to apply the Hungarian method. How will proceed? I am not writing, the space is limited, just I am reading it, telling it, just note down. Okay. So first row wise you find out the lowest element and subtract from all the remaining elements. So for first row, the lowest element is 2 and you subtract 2 from all the elements. And after subtracting, this is actually table 3. The first is the profit one, this is second. Now we are doing that is a third table. So you are subtracting 2 from all the elements of the first row. That means this will be 7, this is 1 in this way, and this will be 2. On the same matrix I am writing just to save the space, but you will do it in different table. This is 8. In this way, the function of first row is over. Now we are taking the second row. Find out the lowest element. Which is the lowest of this row? Is the lowest is 5. You subtract 5 from all the elements. Then it will be 7. 12 minus 5 is 7. This is 5. This is 5. This will be 0. And this will be 6. And this will be 4 in this row. 4. 7, 5, 0, 6, 4. Now for the third row. Which is the lowest element? Lowest element is 0. If you subtract 0 from all other elements, it will remain 7 as it is 0. For fourth row, again the lowest element is 0. If you subtract 0 from all the elements, the elements remain 7. 8 minus 0 is 0. Sorry, 8 minus 0 is 8. 0 minus 0, 10 minus 0 is 10. That's why it is not changing, because you have to subtract the lowest element. Now for the fifth row, the lowest element is 2. You subtract 2 from all other elements of this row. Then it will be 3. Again, this will be 3. And this will be 4. And this will be 0. This will be 0. And this will be 7. So 5, 3, 4, 3. The last row is 5, 3. Sorry, this will be 5, 3, 4, 0, 7. 5, 3, 5, 3. Last one is 7. 7 minus 3 is 5. Sorry. 5, 5, 3, 4, 0, 7. The same process you have to do column wise. I am taking first column first. What is the lowest element? The lowest element is 5. Subtract 5 from all other elements of this column. Then what will be this? This will be 2. You will do it in a different table. Just to save the space, as the space is very limited, I am doing on the same table. Then 5, again it is 2, 7 minus 5, and this is 6, and this will be 3, and this will be 0. 0. I'm checking it. 2, 2, 6, 3, 0. Okay. For the second column, the lowest element is 0. If you subtract 0 from all other elements, it will not change. That's why I'm not doing anything. For this column also, the lowest element is 0. That's why this column will again remain same. Here again for this column, the lowest element is 0. If you subtract 0 from all other elements, it will not change. For this column, the lowest element is 4. You have to subtract 4 from all other elements of this column. Then what will be the figure? 4. 4 minus 4 is 0. 8 minus 4 is 4. 7 minus 4 is 3. And 7 minus 4 is. In this way, 4, 0, 4, 3, 3. In this way, you have to perform the row and column process operation. After completing this, what you have to do, I have shown my previous video also of assignment problem. The same process I am following, which is Hungarian method. Now, try to pass horizontal or vertical lines over all zeros so that minimum number of lines cover all the zeros. No zero should be left out. Again I am repeating, pass minimum number of horizontal or vertical lines over the zeros so that all the zeros are covered. Keep it in your mind, the minimum number of lines. ऐसा नहीं कि ऐसा line खींच दिए. No, number of lines should be minimum, and the line should be either horizontal or vertical. Diagonal is not allowed. This is the rule. Try to pass the line. So just I am taking the different color. It will be better. And use different color to pass the line. Now, say this is one line. This is one line, and you can check this is another line. Cross it, another line, and say this is another line. Pass it, and finally, you can draw at your choice the lines. Only you should follow the rule that minimum number of lines should cover all the zeros, horizontal or vertical. You see, this is the horizontal line, and this is vertical line, like that. Now count the number of lines. How many lines required to cover all the zeros? In this case, 1, 2, 3, 4 lines. I am not writing anything, you will write in your copy. 4 lines are required to cover all the zeros. What is the order of the matrix? Order means 5 by 5 in this case. 5 row, 5 column. If the number of lines and order of matrix is same, then you should stop. That means you have reached to the final table, and on that table you should only put the allocation. But if it is not so, if the number of lines is lesser than the order of the matrix, then you should proceed further. So in this case, the number of lines is less than order of matrix, because your order of matrix is 5, but your lines is 4. So 4 is less than 5. That means you should proceed further. What you will do next? The next process will be, you find the lowest element which is not touched. From the untouched elements, you find out the lowest element. The first. What I am telling you put as a rule. That is the rule. So 2, 1, 2, these are the left out elements which are not 6, 2. Which is the lowest? This is the lowest element. Now what you will do, you subtract this lowest element from all the remaining elements. This is not remaining elements. I am doing, and this lowest element has to be added. You have to add to the junction point where horizontal and vertical lines are crossed. At this point, this lowest element is to be added. Here is a junction point, here is a junction point, here is a junction point. You have to add it. You have to add. And the elements which are covered, that will remains same. Is it clear? Now I am using better another color, that is a red. 1 is to be subtracted from, as this is the lowest element, from this. This will be what? 1, and this will be 0, and this will be again 1. Okay, and this will be 3. This will be 3, and this will. As the number of lines are less than the order of the matrix, for that reason you have to proceed further. What steps you have to follow? Now I am going to discuss for that. What you have to do, find out the minimum element from the remaining elements. Remaining means this, not this. These are the remaining elements, not this. You have to find out the minimum value, lowest value elements from the remaining elements which are not touched by the horizontal or vertical lines. In this case, the minimum number is 1. This is the Hungarian method we are following. And what you have to do, subtract this minimum number from all the minimum elements. All the remaining elements. Subtract this minimum or lowest element from all the remaining elements and add that lowest element to the junction point. This is the junction point where horizontal and vertical line touches, crosses. That is the junction point. You have to add that number to the junction point, and all the other elements which are passing over the lines will be remains same. I am doing by the red marker on the same matrix or format so that I can save the space. Due to problem of space, I am doing on the same format. But you do it in a separate page. So you have to subtract this lowest element from all the remaining elements. If subtract 1 from this, then what will be the value? Then this will be 1 and this will be 0 and this will be 1. Subtract from this also 4 minus 1 is 3 and subtract this, that is 5 and it will be 1. This will be 1 and this will be 8 and this will be 3. Okay? This is. But that lowest number is to be added at the junction point. If you add this 6 plus 1, that is 7. It will be 7, and if you add to this junction point, then it will be 4. And if you add to this junction point, then it will be 1. And but all other elements will remain same. That is this side you will not change it, whichever is possible. Now, as we are using the same table, that's why we are erasing this. This is 0. This is 0, 1, 0, 1, 0, 3, and just I am writing in a fresh way. It will be better to use for that. That's why you just note to your copy. Okay, a second row will be 250. This is 2 5 5 0 250 70 7 and 0. This is 518. This is 0. This is 0 and 3 and realize it in fresh way. Writing on this. Okay. Mm-hmm. 3010. This is 3 0 10 4 3 4 3 4 3 0 3 4 0 3 and 4 1 3 1 and 3. Okay. Now again pass minimum number of lines to cover all the zeros. The line should be horizontal or vertical. Okay. Then by using the different color, which of the lines required to cover it? 1 0 1 0 3 2 5 0 7 0 5 1 8 0 3 3 0 5 8 0 3 0 10 4 3 4. And again pass minimum number of lines to cover all the zeros. How many lines will be required? You check it. This is the 0 1 line. So cross this 1 line, and again you can draw different line as per your. This is a straight line, okay? And sorry, and this is another line, straight line, and this is another line. I think all the zeros has been covered. And how many lines are required to cover all the zeros. Number 1, 2, 3 and 4. Again 4 lines are required to cover all the zeros. That means we have not reached to the optimum. We have to proceed further. The same process we have to repeat. What is the same process? How many lines? What is the process? Find out the lowest element from the remaining elements. This is the remaining elements 1, 3, 3, 8, 10, 4. These are the remaining elements. And what is the lowest element? The lowest element is 1. Subtract this lowest element from all the remaining elements and add this lowest element to the junction point. You have to add it to the junction point, and all the other elements which are touched or covered will remain same. The same process we have done in the previous step, you have to follow it. And this is Hungarian method. Okay, then I am writing in different color. It will be better. Look, it will be better if I write this. Okay. By blue it is better. Blue we have not used it. That means it will be, if you subtract, it will be 0 and it will be 2. This is the lowest element 2, and that it will be 2. Again this will be 2 and this will be 2 and this will be 3 and this will be 9 and this will be 7. These are the remaining elements, and you have to add to the junction point. That's why this will be how much? The junction point 3 plus 2. That's why you have to add, and this will be, what will be the amount? 6. 5 plus 1, 6, and this will be 7 plus 1, that is 8. And all these elements will be remain same. Now as we are using the same table, that's why I am keeping this. This will be 1. It will be not changed. Change হবে because it is on the lines. So 3 and this will be 5, 5 and this will be 3, 3. This will be 0 and this is 3. This will be 0 and this will be 1. This will be 1 and this is your junction point, and this is 9, 3 and this is 0, that will be 4 as it is, and that will be 1. The revised table will be like this, as we have done earlier. Again, you have to pass horizontal, you will remain same. Just start checking is there any mistake or not. This will be 0, this will be also 0. So this is the revised table. 1 0 0 1 0 2 3 6 0 8 0 5 1 7 0 2 3 0 9 4 2 0 3 3 1 2. Okay. Now again pass horizontal or vertical lines over all the zeros and check the minimum number of lines is required to cross all the zeros, and you can check it that 5 lines are required. This is one line will be required, 2, 3, 4, 5 others you can draw in this way also. I have checked. Actually I am not disturbing this table because the final allocation I will get on the same table. If you try to draw, just I am showing it. Say this is one line if you draw one line and to cross this another line is required, to touch 0 this is another line, and for 0 is here 0. 5 lines are required. In this step you can check the minimum 5 numbers of line are required to cover all the zeros. 5 numbers of horizontal or vertical lines are required to cover all the zeros. You can check in any way. You can see the minimum number, not more than that, minimum number of lines. You cannot cross all the zeros lesser than 5 numbers. It is not possible to cover all the zeros by 4 lines, horizontal, vertical. You can check it. So, as 5 numbers lines are required and the order of matrix is 5, we have to stop here. Now, what you have to do? You have to start the allocation process. Don't confuse. I am not right. Just not writing the lines to use the same table for allocation. But you have to do in your exam that 5 lines are required in this way, second line, third line, fourth line, fifth line. Or if you draw in this way, second, third, fourth, fifth. It is not possible to cover all the zeros lesser than 5 number of lines. You can try it. As the order of the matrix and lines, minimum number of lines are same, that means we have reached to the optimum, and this is the optimum table. And from here you have to start allocation. Now I am going to start the allocation. How will start allocation? You see in this row only in 1 0 is here. So the allocation should be put on 0 only, not here allocation. Allocation means allocation of job with machines. In this side machine, 5 machines are here and 5 jobs. Which job are to be attached to which machines? You have to allocate from this table, and the allocation will be made on 0 only. The clue I am telling you, as in this line you see only 0 is there, you have to put allocation on 0. You must have to allocate this. If you not allocate this one, then what will happen? There is no other 0. This is a common sense. If there is no other 0, then this machine will be left out. ये तो नहीं हो सकता है ना. All machines should be used. It should be attached with the job. That's why I have allocated here as there is only 1 0. And once it is allocated, then you have to cross it. Sir, why you have crossed it? The reason is, once you have allocated, that means B job is allocated with 4th machine. And once B job is allocated, this job cannot be allocated with any other machine. That's why, and your allocation is to be made on 0 only. That's why it is not acceptable or possible to allocate on this 0, because already B has been allocated. You see the last row, there is only 1 0. It is also to be allocated, otherwise P machine will be left out. That's why I have allocated. But here is no 0, that's why it is not required to cross it. Now start from the first row. You can also start from the first row, serially, first row, second row, third. In many books, some processes are mentioned for allocation. But if you want to follow that process, then it will take a lot of time. But I have checked and seen the practical approach is not very problematic, and it will take very lesser time. Now I am starting to allocate serially from first row. This is mandatory. There is no alternative. That's why I have allocated it. Why mandatory or must? That I already discussed. Because 1 0 is there and one allocation is to be made. That's why you must have to allocate. That's why I have cleared it first. Now suppose I am allocating this first zero. At the moment you are allocating, the remaining horizontal and vertical zero you have to cross. There is no scope for allocation because this job has been allocated with this machine. Again you can allocate it, you cannot allocate on that job. That's why I have strike out it. And this is also not acceptable because this machine has already been allocated. This machine cannot be allocated for this job. Now the remaining zero is 0. It is possible to allocate it, and this 1 0 is left here, and that's why it should be allocated. In this way you can finalize the allocation. Then what is your allocation? The machines, I am writing here machines, and this is jobs. This is the 1 2 3 as there is no space, that's why I am writing right side. What you should write just below this matrix 3 4 5. For first machine, which job will allocate? For first machine you have to allocate C job. For second machine, which job you have to allocate? This is E. This is E job is to be allocated. For third machine, which job is to be allocated? D. That is this. And for fourth machine, which job? That is B. This is B job. And for fifth machine, which job? This is A. To capture A, B, C, D, E. In this way, you have to allocate. This is the best allocation. And what will be the profit? That is also to be calculated. We have to calculate that is also. Now I am using this matrix. I think it is clear. Again I am repeating. If you have any doubt how we have made allocation, because there is only 1 0 in this row, you block it first. There is only 1 0. That's why I have blocked it first. That is, you have made allocation here. You have to make allocation only 0. And as once you have allocated, no other allocation is possible. That's why you have crossed it. Okay. Now from remaining you have to allocate. First 0 you have taken for allocation. That's why you cross it. No other 0 is possible vertically or horizontally. In this way you have made the allocations of 5 jobs with 5 machines. How will allocate? That I have noted. Now what will be the maximum profit? This is the allocation, and now I am going to find out the maximum profit. How we calculate it? That I am going to show you. Okay. Fresh way, I am writing here. Fresh way. That is your allocation will be in this way. Machines, and jobs, and profit figure. This is your final answer. Machines 1, 2, 3, 4, and 5. First machine is to be allocated with job C. Second machine is to be allocated with job E. And this is D. And this is for B. And finally for fifth A. And what will be the profit? The profit figure you have to take from the first table, because the profit figure is given to the first table. So if one is allocated with C, then what is the profit? C, the maximization profit, that is 10. You can check for the first matrix. For if the machine 2 is allocated with the job E, the profit will be 5. This is 5. And if the third machine is to be allocated with D jobs, you check from the table, that is 40. The profit is 40. You have to take the profit from that table. If fourth machine is allocated with the job B means the profit is 40. And if fifth machine is allocated with job A, now profit will be 7, and this is the total profit. And what profit? Then what is 0, total is 2, 3, 5, 50. This is the profit, total profit. This is your answer. That is, what is your answer? Your answer is that you have to allocate all these bases corresponding jobs and this is the profit. This is the answer. If you have any problem, you please write to the comment box. I will definitely reply at the earliest possible. So I think it is clear. So just I will again recap. This is a maximization problem. That's why first you have to convert the problem to the minimization problem. The process I have already discussed. And after that you have to apply the Hungarian method, because Hungarian method is for minimization of the assignment problem. And after doing the final step of allocation, again you will take the figure of the profit from the first table, and in this way you can solve the assignment problem for maximization. Thank you, and if you like this problem, then put one like also, and if you have any problem, you just write to the comment box. Thank you very much.